All right. Are we ready? Are you guys ready at the back table? Nate, you guys ready? Ready? Okay. The circumcenter is where? The perpendicular bisectors is where the perpendicular bisectors are concurrent. Perpendicular bisectors are perpendicular to one side and bisect the other side, or the opposite side. Well, they're perpendicular to the side and bisect it, I guess you could say. Not the opposite side, and bisect the side that they're perpendicular to. Sorry, I said that weird. They're perpendicular to one side and they bisect the side that they're perpendicular to. It makes more sense if you look at the pictures. So if you look over here, you can see here's kind of a nice picture. If we had an acute triangle, so all the angles are less than 90 degrees. So here's one perpendicular bisector. So you have a line, it's perpendicular to this side, and it cuts it in half. That's what bisect means, cuts it in half. Here's another one. So here's the side. This line is perpendicular to it, and it cuts it in half. Here's the third side. This line is perpendicular to it, and it cuts it in half. So if you draw all three of those perpendicular bisectors, then the place where they intersect each other is called the circumcenter. That's what that means. This one with an obtuse triangle makes people a little bit less comfortable because then that center of the triangle is actually outside of the triangle, and so that makes people like a little bit uncomfortable because you're saying that the center of the triangle is not inside of it, which is like a little bit weird. This one is kind of cool because if you have a right triangle, so this is a right triangle, then the circumcenter is on the hypotenuse. If you have a right triangle, then the circumcenter is on the hypotenuse. Just an interesting fact. And not only is it on the hypotenuse, it's actually in the middle of the hypotenuse, right there in the middle. Okay, so let's go ahead and fill out these other facts about the circumcenter. The circumcenter is also the center of the circle that can be circumscribed about the triangle. The vertices are equidistant from the circumcenter. So these two ideas are kind of tied together. So basically, if you were to start and say that the circumcenter is the center of the circle, then you could say from the center of the circle to the vertex, or to each vertex of the triangle, each corner, then this would be a radius of that circle that's circumscribed. This over here would be a radius of that circle that's circumscribed, and this over here would be a radius of that circle that's circumscribed. So all three of those would be a radius of that circle. They'd all be the same length. And then from there, once you have each corner or each vertex of that triangle, then you could draw a circle that touches each corner of that triangle. Does that make sense? It's not a corner because there's not four of them, but you get the idea. Each vertex of the triangle. So same thing over here. If you did, there's one radius, the second radius, there's the third radius. It's a less comfortable picture, but it works the same way. And then if you were to draw a circle that starts with those that has that same distance all the way around, that circle hits all three vertices of the triangle. It includes the entire triangle, and it hits all three vertices. So from here to this vertex, that's the radius, that's the radius. From here to here, that's the same distance, it's the radius. So they're equidistant. Third thing, the circumcenter does not have to be inside the triangle. That's important. Circumcenter does not have to be inside the triangle. Okay. This is just an interesting fact. It is not something that will even show up on the Math 3 EOC. It was just something I found that I thought was kind of cool. Leonhard Euler, that's how you say his name. It is the number E you guys have seen before, 2.71. It's on your calculator. We've talked about it. Leonhard Euler noticed a relationship between the three classical triangle centers, that they are collinear. The word collinear means that they're in a straight line. They're in a straight line, not a zigzag, but a straight line. The centroid is always in the middle of the other two, and the distance between the centroid and the orthocenter is always twice as much as the centroid and the circumcenter. So it's like a 2-to-1 ratio, if you look at that. The line that these three centers of triangles lie on has been dubbed the Euler line. So, not Euler, don't say Euler, then you sound like a silly American who can't pronounce things correctly. It's Euler. All right, next page. The next one is not a classical triangle center, but we're going to study it anyway. It's the incenter. The incenter. This is where the angle bisectors are concurrent. Where the angle bisectors are concurrent. So you can kind of imagine, now that we know what a perpendicular bisector is, that that's something that cuts a line in half. An angle bisector cuts an angle in half. So you can see from the picture, we have lines that are cutting this angle in half, cutting that angle in half, cutting that angle in half. And then that is what creates the incenter of the triangle. So the incenter is also the center of the circle that can be inscribed inside the triangle. So if you look at this, the sides of the triangle are equidistant from the incenter. So if this is the incenter, if you look at the distance from the incenter to this side, from the incenter to this side, from the incenter to that side, that's how you would see what the radius of the circle is. And then from there you can kind of draw the picture. So if you could draw any triangle on your page, go ahead and just like sketch a triangle, and you can make it look different from mine. I just want you guys to see how easy it is to kind of draw the incenter and draw that inscribed circle. So if you can kind of just visually like cut those angles in half, so look at like there's kind of the middle of that angle. Let's say like there's kind of the middle of that angle. There's kind of the middle of that angle. It's pretty easy, no matter what your picture is, to find the incenter of the triangle. So there's kind of my incenter. And then from here, if you want to find the distance between the incenter to the edge of the circle, you're just going from the incenter to the side, incenter to the side, incenter to the side. And then there's your inscribed circle right there. So that's kind of what they're talking about, is if you were to draw that line from the incenter to the edge, making that a radius. So this right here, this is the radius. This is the radius, this is the radius. These right here, these were the angle bisectors. I'm going to write AB for angle bisector. So we're not saying that the angle bisectors are the things that are the radius of that inscribed circle, but we are saying that if you have those angle bisectors and they create an incenter, then you also have this other situation that is true where you can draw an inscribed circle, which means you'll always be able to have a circle that fits perfectly in the center of that triangle, with the incenter as the center of that circle. Okay. And you guys can see that the incenter, and it kind of makes sense if you think about it, that if you have your angles being bisected and that creating the incenter would always have to be inside the triangle for these. Okay, so that's going to be something I'm just going to add on the bottom. It wasn't printed, but it's good to know. It has to be inside the triangle. So what I've noticed as I've been teaching about this is that some of these questions on the EOC are mathy questions and some of them are factual questions. So the notes that you guys took last night, this set, these are all facts about the orthocenter, the incenter, the circumcenter. These are specifically math facts. We haven't done a lot of math yet. Okay, so these are the types of things, maybe you put it on a flashcard or something. Obviously, you're going to put it on your cheat sheet. But these are the types of facts that you're going to try to memorize. These are multiple choice questions. You get it right, you get it wrong. There's not a whole lot you can do to figure it out aside from you just memorized it. Does that make sense? When it comes to studying for the EOC, these are not ones where I can give you a shortcut on Desmos to like cheat it out and figure it out. These are ones you either know or you don't. Does that make sense? Okay. All right, I'm going to go ahead and give you another sheet of notes, and now we're going to do the mathy part, the ones where, okay, there are some of these we can actually do some math, and some of them we really can't. All we know is the facts. So, all right, so for the mathy notes, are you guys ready? We're starting off with the centroid, so go ahead and look at your non-mathy stuff and look at the centroid. It says to find, from the centroid, find the coordinates of the centroid of the triangle, which we can find because I do believe I put this on the notes on the video. Can everyone find it on the notes on the video? Yes, it's on the first page. So let's go ahead and write down the coordinates of G and H and I, because we're going to need all three of those. So G is right 2 down 4. H is left 1 down 7. And I is left 4 down 7. Okay. And then it says on the notes, if you're working in a coordinate plane, the centroid can be found by taking the average of the x coordinates and the average of the y coordinates. So how do we do the average of something if we have 3 numbers? Add together, divide by 3. Okay, so for the x coordinate, we're going to do 2 plus -1 plus -4 divided by 3. And then for the y coordinate, we're going to do -4 plus -7 plus -7 divided by 3. So what do we get for the x coordinate? -1, okay. And then what do we get for the y-coordinate? -6. You are a genius. Thought that was quieter. Yeah. Yeah. All right. So we just have to add the 3 x coordinates up, divide by 3. Add the 3 y coordinates up, divide by 3. Okay? All right, for the next one, it says the centroid divides each median. Remember, the centroid is where the medians are concurrent. It divides the median into a 2-to-1 ratio. The length of the portion of the median that is closest to the vertex is twice as long as the part that is closest to the side. So the part to the vertex is twice as long as the part that's close to the side. Okay, so if we look at this, if this part here is 10, then this part here is what? 5. This part is twice as long as that part. It had to be one or the other. It had to be one or the other. You're good. Okay, so AG is 10. That makes that 5. Okay, and then we also know, what about medians? Did I define a median? It bisects the opposite side. So if it bisects the opposite side and this is 8, then what's this? 8. Okay. All right. So we have BD is 8. Okay. From A to B is 16. From E to G is 5. From A all the way to E is 15. And then, C to G and D to G, we're not sure. Okay, so from C to G and D to G, we have to use our 2-to-1 ratio. Okay, so what I'm going to do here is I'm going to call this a length of 2x, and I'm going to call this a length of 1x so I can see my 2-to-1 ratio. Is everyone okay with that? My 2-to-1 ratio? All right. So I'm going to go ahead and say 2x plus 1x, and there's a typo. I accidentally got my picture here too close to the number of what CD was supposed to equal. It says CD equals something, and then it doesn't tell you what. CD was supposed to equal 18, so that's a typo in the instructions. It was supposed to be there. So the length from CD is supposed to equal 18. So we're going to say 2x plus 1x equals 18. And so that gives us 3x equals 18. So what does x equal? X equals 6. Okay. So that means that this part right here is 6, and then this part right here is what? 12. Okay. So C to G is 12. D to G is 6. Okay, so all of that we got either by using the 2-to-1 ratio or by saying that a median bisects the sides, it cuts the sides in half. Is there any part of that we are uncomfortable with? 2-to-1 ratio, cut the sides in half. Okay, next we have the circumcenter. So go ahead and take your old notes, turn the page. Look at the circumcenter. Okay. Okay. So for the circumcenter, it says in the diagram we have perpendicular bisectors, ABC. They meet at point G, the circumcenter of the triangle. Find the indicated measures. Okay. So we have perpendicular bisectors. So we know if this is 20, then what should this be? 20, and we know that why. It's a bisector. Yeah, it cuts it in half. Okay, so if this is 15, then what's this? 15. And if this is 24, what's this? 24. Okay. Now, circumcenter, is very similar. It reminds me of the word circumscribed, right? Circumscribed. So this is where I always make sure for the ones that have a circle that I draw my circle and I remember which part is my radius, okay? So do you guys remember with this one where we get the radius from? We have this is the center of the circle, and then where do I get the radius from? You might have to look at your notes for circumcenter. Where's the radius come from? Is it the dashed lines? Is it to the opposite sides? Is it to sides or is it to something else? It's to the vertices. Okay, so if you need to do something, if you need to add that to your notes somehow, then that should be something you guys should do right now, because when I asked you the question, nobody could answer it. So right now, write something on your notes. Maybe you should say the radius, that the vertices are the radius of the circumscribed circle, but put something in your notes so that you know what that means, because that's really important for these questions. It's going to make your life easier if you can remember that, okay? So the radius is created by going from the center of the circle to the vertex. Here's the radius. From the center of the circle to the vertex, there's the radius. From the center of the circle to the vertex, there's the radius. And then from there, maybe I can draw a good circle here. That was okay until I got to the upper left part. Then I got wonky. Okay. So now you can see it a little bit better. So from G to C, I have a radius of 25. So from G to A, I'm going to have what? A radius of 25. And then from G to B, what am I going to have? A radius of 25. Do you guys see how that's helpful? Okay. So whenever I'm doing a circumcenter or an incenter, I always draw the circle because that's going to give me a bunch of extra lengths. Does that make sense? And once you draw the circle, it's a lot easier to recognize what those lengths are. You can see the radius a lot more clearly. Okay, so A to G is what? 25. B to D, 20. C to F, 24. A to B, 40. C to E. A to C, 48. The measure of ADG. Angle ADG. 90 degrees. How do we know it's 90 degrees? Yeah, these are perpendicular bisectors. It's a circumcenter, which means that those lines have to be perpendicular. So that's a 90-degree angle, okay? If BG is 2x minus 15, how do we solve for x? BG is 2x minus 15. How do we solve for x? Okay, then we can add the 15 over. So 2x equals 40. And then what would x equal? 20. Okay? All right, next one. It says lines A, B, and C are perpendicular bisectors. Solve for x, for y, and for z. Okay. Anything you guys can see? Yeah. How could we solve for z? Yeah, so these two sides right here are both going to be 18. So 7z plus 4 equals 18. So that's the only part that it looks like they used that utilizes the fact that it's a bisector, that it cuts it in half. Everything else utilizes something else. So perpendicular bisectors, we're still talking circumcenter. So now I'm going to go ahead and do my circumcenter part with the circle, circumscribed. So I've got the center of my circle, I've got the vertex, so here's a radius. Here's a vertex, so there's a radius. There's a vertex, so there's a radius. And then I've got my whole circle there. The bottom wasn't great. Okay, so I got a radius, and a radius. So how am I going to do the rest of it? Okay. Okay, and then 5y minus 6 equals 24 as well. Okay, so minus the 4 over 7z equals 14. All right. How do your brains feel right now? Pretty good? Are you okay? Your brain died a while ago? That's unfortunate. When you first walked in, before we even did math, you were just like, and done. That's how students always feel. Keep telling them, if you have me as a teacher, it's just, that's what it is. No. We talk about dead birds, we have homework, you know? It's life, you know? All right. In center. So in the diagram, we have an isosceles triangle. Do you guys remember what an isosceles triangle is? Two sides are the same, and the angles are the same. So two sides have to be the same measurement, like the same length, and then two angles have to be the same degree measure. Okay, so we have an isosceles triangle. They say that AB is congruent to CB. So we know that this length and this length have to be the same. If AB and BC are the same, then what are the angles that are the same? So then the whole corner, like all of A and all of C, those two corners have to be the same. Okay. So angle bisectors AD and BF and CE are drawn and they intersect at X. So they said that we have angle bisectors that are drawn and they intersect at X, which means they are telling us that this is an in-center because they called those angle bisectors. Okay, they say that angle from B to A to C, B to A to C, this whole thing is 50 degrees. The whole thing is 50 degrees. If the whole thing is 50 degrees, what do we know about the little angles? They're each 25. Okay, so I'm going to label them as each being 25. 25 and 25. Overall, that's 50. Okay. Do we know anything about over here? They're going to have to be the same because why? Because it's an isosceles triangle. Okay. All right, the problem says find the measure of AXC. Find the measure of AXC, angle AXC. How are we going to do that? Yeah, AXC is right up here. So we're going to do 180 minus 25 minus 25. And then what do we get? 130. Okay. Next, point T is the incenter of PQR. PQR. It's the incenter of PQR. Okay. So if it's the incenter, let's make sure we're looking at the incenter notes. Now this picture doesn't have anything to do with angles. This only has to do with lengths. So what part of the notes are going to be helpful for us with the lengths? That had to do with centroid. Incenter is the very last page. So where could lengths come into play on incenter, do you guys think? The radiuses, yeah. So with an incenter, that means we have an inscribed circle. That means we can somehow draw a circle inside the triangle. So where is the radius in this picture? Is it from the center to the vertex? Okay, it's from the center to the side of the triangle, from the center to the side of the triangle, from the center to the side of the triangle. Okay, so here's the circle. That was pretty good. That's a pretty good circle if I do say so myself. Okay, so we got a radius, we got a radius, we got a radius. Okay, what is the length of ST? 15. All right, TU is 2x minus 1. How do you find x? So that's equal to 15. 2x minus 1 equals 15. And so x equals 8. Okay, now we've got some angle questions. Okay, it says PRT. From P to R to T. PRT is 24. So then QRT is what? 24, okay. So QRT is the other side, which had to be 24 as well. Because if you're an in-center, then they must be cut in half. Okay? The first one or the second one? RPQ. Okay, so R to P to Q, RPQ, so that's the whole thing. RPQ is 62. If RPQ is 62, then what is RPT? 31. Then RPT is 31. Ta-da! All right, how do you guys feel about the centers of triangles? Okay, do you guys see how the difficulty of today is memorization, not necessarily the math? It's going to be familiarity. Okay, so make sure today that we're not leaving all of this till the last minute. The important thing for today is not only do we finish our practice assignment, but also that we get this stuff onto our cheat sheet, because today has a lot to add to the cheat sheet. Do we see that? Okay, do we remember where the videos are to add stuff to our cheat sheet? Where can we find the videos? It's where the answer keys are within the module. So if you click on the module on Canvas, it's the very first link at the bottom of that page. Okay, I'm going to go ahead and hand out the